Hello dear students, how are you doing? Students, in previous lecture 7, we have seen about the concept of definite integral. Today, we'll continue to the last concept of this chapter, which is about application of integral calculus. So, in this chapter, the integral calculus has a lot of applications, especially in mathematics. In mathematics, we'll use integral calculus to calculate area and volume. In addition to this, in physics, we will apply this integral calculus to calculate one work done by variable force, to calculate acceleration, displacement, and so on. It has a lot of application even in economics, in chemistry, and so on. So today we will try to see these applications. Now let's see how to calculate area between two curves. If we have this curve, assume this is the function f of x. If we are asked to calculate the region bounded by this curve and x-axis is assumed, x-axis, to calculate this area from interval a to b, simply you apply this equation. So the area of this region is the integral of the function f of x dx from a to b. Second, if we are asked to calculate the area between this negative function f of x and x-axis on interval a to b, that means this area. So we apply this equation. Simply, area is equals to the integral of this function f of x dx from a to b, but it is negative because it gives you this negative value. So area must be positive, so you put negative in front of it. Now next, the third one, the area between two curves. Let's see this one. If you have one function here, f of x, and the other function, g of x, if you are asked to calculate the region bounded by these two curves on interval, assume the interval a to b, take this interval a to b. So to calculate the region bounded by these two curves, this area, simply you apply this formula. So area is equal to the integration from a to b of f of x minus g of x upper function minus the lower function. So we apply this formula to calculate the area between these two functions on interval a to b. Now the fourth one, sometimes you may be asked to calculate the region bounded by the function and y-axis. Look this one. You have a certain function here. That function must be written in the form of invariable y f of y. If you are asked to calculate the area or the region bounded by this curve end, y-axis on the interval a to b. If you are asked to calculate this region, simply you integrate this function on the interval a to b. So this is a formula. Area is equal to simply the integration of the function f of y from a to b. Now the fifth one, sometimes this function f of y may be below y-axis like this. Sometimes the function, this f of y may be here. And you may be asked to calculate the region bounded by this function f of y, the function f of y with y-axis. If you are asked to calculate this region or the area of this region, simply you integrate. This is a function f of y dy from a to b, but you put negative because this gives you negative value, area is positive, so to make that you put negative in front of it. Now next to this you have two functions written in form of written in variable y. One function here, it is f of y, the other function here g of y. If you are asked to find the region bounded by these two curves on the interval a to b, that means this region. If you are asked the area of this region, simply you integrate this function by taking the difference of the two functions. So the area is equal to the integral from a to b of f of y minus the upper function minus the lower function when it's in along y-axis. So it is f of y minus g of y minus g of y dy here, Okay, so now let's see examples for this part. Look the question, find the area of the region bounded by the graph of f of x is equal to x squared minus 1 and x-axis between the interval x is equal to 0 to x is equal to 2. To find that, first you have to draw the graph. So let's try to draw the graph of f of x is equal to x squared minus 1. Look the graph, x, y. The graph of x squared minus 1, as it is from minus 1, it moves upwards a parabola. This is a graph of f of x is equal to x squared minus 1. So we are asked to find the region bounded by this curve in the x-axis from, this is 0, from 0 to maybe 2 is near here. So you are asked to find this region, this area, not on that, this part also. So we need to find this point, the intersection of this function with x-axis or the zeros of this function. So to find that, simply f of x is equal to 0. This means this x squared minus 1 is 0. So x is equal to plus or minus 1, but minus 1 is here. So 1 is, the value of 1 is here. Therefore, we have found this point. Now to calculate the area of this region, we have two areas. Assume this to be area 1 and assume this to be area 2. So simply you evaluate the two areas and you add so that you find this region. So the area of this region, is, as you can see, the curve is below x-axis. The curve is below x-axis. Therefore, so this region is the integration of the function x squared minus 1 dx from this interval from 0 to 1. From 0 to 1, and you put negative because the region is below x-axis. So to make positive, you have to add negative. Next, plus, you add this area. This area is the integral from 1 up to 2, the integration of the function from 1 up to 2, x squared minus 1 dx. So simply you will have this one. So the integration of this, it is x cubed over 3, and the integration of minus 1 is minus x on the interval 0 to 1. You integrate this value, you will value this value. Next, the integration here the same, it is x squared minus 1, it is x cubed over 3 minus x on the interval 1 up to 2. So first you put 1 here, and then minus, you put 0. So you will have this one. Don't forget the minus sign, put a bracket. So put 1 here, it becomes 1 cubed over 3 minus 1. Next, don't forget this one, you put 0. So minus, when you put 0 here, it is 0 cubed over 3 minus 0. So plus the integration of this, when you evaluate this, put 2 first, 2 cubed over 3, that's this 8 over 3 minus 2, then minus put 1 on this value, so you'll have 1 cubed over 3 minus 1. So when you evaluate this, you'll have the following. So 1 over 3 minus 1 is it is minus 2 over 3, so multiplied by minus, you'll have 2 over 3. This part is 0. And 8 over 3 minus 2 is also it is 2 over 3. And this 1 over 3 minus 1 is this minus 2 over 3 multiplied by minus here, so you'll have 2 over 3. Therefore, when you add this, the answer will be 2 square units. So this is the area of this region. Now let's proceed to the second example. Find the area of the region bounded by the graph of f of x equal to square root of x and y-axis between the interval y is equals to 1 to y is equals to 4. So to evaluate this, let's first draw the graph. So the graph of square root of x, this one, this is f of x is equal to square root of x. So we are asked to evaluate the region, this region, the region bounded by this curve and y-axis on the interval 1 up to 4. This region. So to evaluate this region, this function must be written in terms of variable y. It must be written in terms of variable y. So I need to change this function in terms of y. Therefore, you know f of x it is y. Y is equal to the square root of x. So square both sides, you'll have this one. Y squared is equal to this. Y squared is equal to x. Therefore, x means it is f of y. So f of y is equal to this y squared. Therefore, writing in terms of variable, instead of writing this function in terms of variable x, you need to write in terms of y. So this will be this f of y, this is equal to this y squared. So now we can apply the integral formula to evaluate this. So the area of this region will be the integration of f of y dy on the interval 1 up to 4. And we have already found f of y to be y squared. Therefore, this area is equal to the integration of y squared dy from 1 up to 4. As you remember, the integration of y squared is simply this y cubed over 3 on the interval 1 up to 4. So the result will be simply first put 4 on this. You have 4 cubed over 3 minus, and then put 1 cubed over 3. Do you see it? Therefore, 4 cubed is 64 over 3 minus 1 over 3 is this 63 over 3 square unit. So the area of this region is 63 over 3 square unit. Okay, now let's proceed to the other example. Now find the area of the region enclosed by the graph of f of x is equals to square root of x and g of x is equal to x squared. So to evaluate the area, we have to draw the graph. So let's draw the graph and try to evaluate the region or the area. So the graph of square root of x, f of x is equal to square root of x at this one. The graph of x squared is it's a parabola. This it is f g of x. This one is g of x. G of x is equal to this x squared. We are asked to find the region bounded by these two curves. This region. this region. So to evaluate the area, I need to find this point. So this point is the intersection of the two graphs. Therefore, x squared is equal to the square root of x. Square both sides. X cubed is equal to, it is x, this is for x greater than or equal to 0 in the domain of this expression. Therefore, this becomes, it is x cubed minus x is equal to 0, and factoring x, you will have this x into x squared minus 1 is equal to 0. So the value of x is this x equal to 0. For this x is this positive 1 and negative 1. But negative 1 is not in our domain, so the intersection of the two graphs is at x equal to 0 and at x equals to 1. So this point and this point. Therefore, the area of this region is equal to the integration of the function g of x. The upper function is, it is square root of x, the upper function, minus the lower function on the interval 0 to 1. So you'll have this one. So the area will be the integration from 0 to 1 of the upper function is the square root of x minus the lower function is x squared dx. So the answer will be the integration of square root of x, it is x means square root of x means x to the power of 1 over 2. So you add 1 on its power, so it becomes x to the power of 3 over 2 and times 2 over 3. You have this, I think you know this, minus the integration of x squared, this is this x cubed over 3. So from 0 to 1. So first just put 1 on this. You will have this 1. When you put 1, 2 over 3 times 1 to the power of 3 over 2 minus 1 cubed over 3 minus, when you put 0 on this expression, it becomes 0. Therefore, the area will be 2 over 3. 2 over 3, this is 2 over 3, this one is 1 over 3, 2 over 3, minus 1 over 3 is this, 1 over 3 square units. So this is the area of this region. Okay, now let's proceed to the other part. Now let's see how to calculate volume of revolution. Now, if we have a function f of x on the interval AB, if you rotate this along x-axis, you will have this form. You will have this region. You will have this region on this interval from A to B. So, please students try to see how this formula is derived on your text, but for simplicity, now simply I will put the formula. So, the volume of this expression is, simply it is pi times the integration of the function f of x squared. In this case, it's not a function. The square of the function is integrated on the interval A to B, and you put pi. So this is the formula for this case. Now, for the other case, sometimes you may have such a function written in the form of y. So if you rotate or revolve from A to B, if you revolve this along y-axis, you will have this region. You will have this region, this solid of revolution. So to calculate the volume of this region, simply you apply this formula. The volume is equal to this pi times the integration of f of y squared, not f of y squared, the function f of y squared dy on the interval A to B. So this is it. Now, the third the third one, when the volume between two regions. Look, this one. We have two functions. The upper function, assume it is f of x, and the lower function, g of x. So, this region, when you revolve this region around x-axis, you will have this one. You will have this region. This part, the inside is hollow. So you will have this region. So to find the volume of this solid figure, simply you apply this formula. So volume is equal to pi times the integration of the integral of the square of the difference of the two functions. The upper function first, the square of the upper function minus the square of lower function. That means this. It is f of x squared minus u of x squared dx on the interval a to b. So this is it. Now let's see example for this. Now find the volume generated when the area bounded by the line y is equal to x in the x-axis from x is equal to 0 to x is equal to 3. So to find the volume, let's see the graph or the region. So we have the line, or f of x equals to x. We have this line. We have this line. This line, it is y is equal to x, or f of x equals to x. So we are asked to find the region, the volume generated when this line is rotated about x-axis from 0 to 3. So when you rotate this, you will have this is a conical figure. So to evaluate the volume of this expression, simply you integrate the function x f of x squared on the interval 0 to 3. That is, this volume is equal to pi times the integration of our function f of x square it, it's x squared dx from 0 to 3. So the integration of this is simple. So volume is equal to this pi times the integration of x squared is it is x cubed over 3 on from 0 to 3. So put first 3 on this value and subtract by putting 0 on this. Therefore, you'll have this one pi times, when you put 3, it is 3 cubed over 3, minus when you put 0, 0 cubed over 3. So the final answer becomes, it is this 27 over 3 is 9 pi. This one is 0, so the answer it is 9 pi cubic unit. By the way, you can also calculate this simple figure. It's a conical figure. If you remember how to evaluate the volume of a cone, it is 1 over 3 times pi r squared h. Using this formula, you can evaluate the volume of this region, solid region. So this is this volume is equal to 1 over 3 times pi times the radius. In this case, radius is this one, this distance. It is f of 3. F of 3 is this 3. So the radius is this 3, and the height is this distance is 3. Therefore, this is 1 over 3 times pi times 3 squared times 3. Therefore, 3 by 3 cancel. 3 squared is 9. 9 times pi is this 9 pi. So we have got the same answer. Now let's see another example. The area bounded by the graph of y is equal to x squared plus 1 and the line y is equal to 4 is rotated about y-axis. So you are asked to find the volume of the solid generated. So let's draw the graph first. Let's draw the graph. Y is equal to x squared plus 1, this part. this it is y or f of x is equal to this x squared plus 1. And y is equals to 4 is around here. Y is equal to 4. So this part is, it is rotated about y-axis. So when this is rotated about y-axis, you will have this solid region. So we are asked to find the volume. The function the rotated function must be written in terms of y when the solid of generation is rotated about y-axis. Your function must be written in terms of variable y. Therefore, I need to change this y is equal to x squared plus 1 into variable y. So we will have this one, y is equal to x squared plus 1. From this, y minus 1 is equal to this x squared. From this, x is equal to this plus or minus the square root of y minus 1. Therefore, x means it is f of y. Our function f of y is equal to this plus or minus the square root of y minus 1. So the function, the rotated function is this f of y is equal to plus or minus square root of y minus 1. So to find this region, you integrate this function, the square of this function, on the interval 1 up to 4. This point is 4. Therefore, you will have this one. So the volume is equal to pi times the interval from 1 up to 4, the integral of the function f of y, this f of y square dy. Therefore, you'll have this one. Volume is equal to pi times the integration of the function, our function f of y is this one, you square it, dy. Therefore, this equal to this, volume is equal to pi times the integration of the square of this one, just is equal to this y minus 1 dy. Therefore, this equal to the integration of y is this y squared over 2. The integration of minus 1 is minus y. So you integrate this on this interval 1 up to 4. Therefore, put first 4 here. You will have this one pi times, when you put 4 here, 4 squared over 2 minus 4, then minus, again you put 1 on this. So 1 squared over 2 minus 1. So this is the result. So after simplifying this, you'll have this answer. So 4 squared is this 16 over 8. 8 minus 4 is this 4. 4 plus 1 squared is 1. 1 over 2 is 1 over 2 minus 1 is negative 1 over 2 times minus this positive 1 over 2. So the sum of these two, it is 9 over 2. So the answer will be this 9 over 2 pi cubic units. Now let's proceed to the other example, example 3. If the region enclosed by the graph of f of x is equal to x and g of x is equal to x squared from x equal to 0 to x equals to 1 is rotated about x-axis. So you are asked to find the volume of solid of revolution. So to find this, first let's draw the graph. Okay, so f of x is equal to x at this line. If x equal to x is this line, f of x is equal to x is this line, and g of x is equal to x squared. G of x equal to x squared, this part. G of x is equal to this x squared. So this region is rotated about x-axis. I need to find this point, the intersection of the two. Simply you can evaluate the intersection. It is 1. It's 1 and 1 and 0. So when you rotate this, you'll have this 1. You'll have this region. Inside hollow, certain part is solid. So you need to find the volume of this. To find that, simply you take the square of the difference, you integrate the square of the difference of the two functions. First, you write the upper function, square it, minus the lower function, square it, you integrate this. So let's see the answer. So you'll have this one. The volume is equal to pi times the integration from 0 to 1. The interval is from 0 to 1. F of x is upper function, so u squared minus the lower function is u of x squared dx. So this is equal to, volume is equal to this, pi times the integration from 0 to 1 of f of x is this, x it is squared, x squared, minus u of x is, it is x squared. When you square it, you'll have x to the power of 4. So the volume of this expression will be, the integral of x squared is x cubed over 3. The integral of x to the power of 4 is this, x to the power of 5 over 5 on the interval 0 to 1. So first put 1 on this expression, pi times, when you put 1 cubed over 3 minus 1 the power of 5 over 5, minus, when you put 0 here, it becomes 0. So your answer will be this 1 over 3 minus 1 over 5. This will be this 2 over 15. You will have 2 over 15 pi cubic unit. So that's it. Okay, now let's see another application of this integral calculus application in physics. It has a lot of application in physics. Let's take one application, work done by variable force. So the work done by variable force F through a displacement from x1 to x2 is given by this equation. It is work is equal to the integration of the force dx from x1 to x2. So let's apply this equation using integration. So look, this example, we're asked to find the work done. Find the work done when a particle is moved through a displacement of 10 meters along a smooth surface by a variable force. The variable force is given to be this 9 minus 1 over 2x. It depends on displacement, so this force is a variable force. So to evaluate the work done by this variable force, you use this formula. So work is equal to, it is the integration of f. F is this 9 minus 1 over 2x dx on the interval 0 to 10. The object moved 10 meters. So assuming the starting point is 0, so the final position is 10, so you integrate from the interval 0 to 10. Therefore, the integration of this will be this 9. The integration of 9 is 9x. The integration of half of x is this x squared over 4 from 0 to 4. So first put 4 on this equation and then 0. You'll have the answer. You'll have this. When you put 4 here, when you put, I'm sorry, this must be this, 10. This is the object moved from 0 to 10. So this must be 10 from 0 to 10. When you put 10 here, it's this 9 times 10 is 90. When you put 10 here, 10 squared, it's 100 over 4. Minus, when you put 0, the whole thing becomes 0. 90 minus 100 over 4. 100 over 4 is 25. 90 minus 25 is this 65. So this will be 65 joule of work will be done by this variable force. So this is all about today's lesson. So I will see you on the next lecture. Until then, goodbye.